Introduce my PhD student, Supicha Monsri, who is the brilliance behind these two presentations today. I'm Supicha's primary supervisor, so she and I will be given two presentations. I'll give the first one, Supicha will give the second, but this is her work. So, and these are two presentations that we both recently gave. In Vancouver. So a few weeks ago we went to Vancouver, she and I, and we went to the 16th, I think, or 15th annual climate change conference there. And it was very interesting. There were scientists from all over the world talking about climate change and what we know about it and how we should be mitigating it and how we need to adapt to it. So it was very interesting. And Vancouver is very similar to Christchurch. It's a low-lying city, has some really areas that they have built on wetlands and very low areas that are all completely developed. Similar to Christchurch, we have a similar situation where Christchurch was built on a wetland and a lot of very low-lying areas, and then we have those rivers going through the city, and around those rivers, low-lying areas subject to flooding, and it's only going to get worse with climate change. So that's really what our two presentations are all about. Okay, so picture yourself waking up to this spectacular view of the Avon River. I don't know if you guys have walked along the river, but imagine yourself waking up. You're in your home, you're looking out the window at this spectacular vision of the river. The river's beautiful, powerful, and life-giving, and every day it moves and inspires you to do your very best. It's really the reason why you've moved to Christchurch, is this view. But more and more you notice that the water level of the river is spilling over the banks of the dike and where your house is located. You're wondering to yourself, will the water soon flood your home? And what will the city do to protect you and your family? Will they build a higher dike? Or perhaps they might build a wall. But then, what about your view of the river? And what will happen when the dike or the wall fails? And it will fail. So we have to stop the river from rising, but how do we do it? Now, under climate change, coastal cities like Christchurch, all over the world, have a high risk of flooding to a condition called the pincer effect. So on the one side of the pincer, so over here, where the ocean is, so this is Christchurch, and section through, right? So here we are. On this side of the pincer, you have an increased sea level rise, which is pushing the water from the ocean up the rivers towards the city. On the other side of the pincer, so over here from the inland, you have an increased frequency and intensity of storm events. So more and more water coming down on the land from the inside here, from the terrestrial areas. And it's going to increase the amount of water entering into the rivers from the inland areas. So when this happens, when the two sides of the pincer closed, so from the ocean and from the inland, you're going to have substantial flooding occurring, and especially around areas that are low-lying, adjacent to our rivers. For example, under this pincer effect, this is the flooding projected to occur in Christchurch, so quite substantial. Structures such as dikes and walls are currently popular for ways for cities to protect us from flooding. But these structures are known to fail, even under very low levels of climate change. They're not fail-safe. So they've failed in the Bay of Plenty in New Zealand in 2017. They failed in other areas of the world, Japan, California, Western Germany, and China. Now, one of the key challenges we have in flood mitigation planning is that we don't know when and we don't know how much flood protection will be needed in the future, because climate change science is uncertain. We don't know what's going to happen. So to help us plan for this uncertainty, the IPCC, which you know is the international body of climate scientists, help us come up with 3 different possible future scenarios in terms of how much climate change will occur and therefore how much flooding we can expect. So they have minor, moderate, and major climate change scenarios associated with flooding at different points of time through the future. So for one, just for an example, between now and 2050, the IPCC are projecting between a 6 to 8% increase in runoff volume in one Christchurch, New Zealand catchment. So that's going to lead to, depending on the scenario, you're going to, especially under the more major, you're going to still get flooding happening before 2050, if that indeed is the scenario that plays out. But between 2050 and the end of the century, the variation is much greater, or the uncertainty. It could be anywhere from 6 to 25%, which means substantial flooding in the catchment. So then we're looking at a much higher level of flooding in this particular catchment, and that's what we're facing at the moment. So how do we plan for this uncertainty? There's a high risk of, we don't know which scenario will play out, and therefore it's difficult to design a cost-effective wall to protect us for the future. There's a high risk of overinvestment, so building too high a wall, spending way too much money, which means we can't spend it on other things in our city, or even worse, underinvestment and failure. We need a more adaptive approach through time for flood mitigation planning so that we can respond to increasing certainty as climate scientists come to agreement as to what's going to occur in the future. So what can we do to protect our cities, to protect our home and its beautiful view? So to figure this out, we're going to pretend that we're back in our house by the river, and it's the future now, and climate change has occurred with a vengeance. The tide continues to rise, and storms are frequent and intense. And just like our dike, our roof is leaking, okay? So what do we do? When your roof is leaking, what do you need? You're just going to let it pour down through the ceiling into your house? What are you going to go get?
Bucket?
A bucket. Thank you. A bucket. So, we need lots of buckets. It's the same for low-lying cities. We need more buckets. The bigger, the better. Okay? So here we see all these buckets that we've put now into the ground that are ready to contain our water. So these additional buckets will help us in 3 ways. First, they'll allow the city to hold more water, and we can do this adaptively as climate change plays out. Okay, so we don't just have the river anymore, we have other buckets, places to hold the water. They'll help reduce the risk of failure of public infrastructure, so our dike systems, our walls, and things like that that are currently in place. And lastly, if the public infrastructure fails under this pincer effect I talked about and flooding occurs, our backup system of buckets will kick in and help protect us from this increased flooding. The question is, though, where do we put the buckets? This is the landscape we're dealing with now. It's already developed, right? How many areas do you see here that we could put big buckets in? to hold the water. And this is the challenge. We don't have public land available to put the water, the buckets in anymore. Well, many coastal cities, though, around the world are putting in small buckets, what we call green stormwater infrastructure. You guys have taken engineering. Have you been introduced to that concept? So these kind of small buckets that can contain water around the city. Most of them are located on publicly owned land, things like rain gardens, swales, green roofs, and porous paving. So you see the pictures of those structures here. And we've dotted them throughout the city, mostly on public land, but also on some residential properties as well. But on residential land, they're really difficult to implement. Not everyone wants one of these structures on their land, and then who's going to manage it after it's been implemented? How do you get on someone's land to make sure it's still functioning? So it's got challenges. In addition to that, scholars have concluded that these systems will not be able to handle flooding associated with the moderate to major climate change projections, especially in the long run. So they just don't have the capacity to serve the purpose that we're looking for. What we asked is, what about another solution? What if we also implement these buckets on large industrial, commercial, or institutional privately owned properties in the city? Ones that are already developed that we can retrofit or redesign and put these big buckets in. We'd then be able to, so there they are there, much bigger land, and we can put in great big buckets, things like detention ponds and wetlands, which you can't put in a narrow strip down a street, right, or on a boulevard. To hold this much water, though, these properties need to have specific characteristics. They need to have the large areas on the properties to build these big buckets. We need to have large depths to the groundwater so that our buckets are nice and deep. We also need large areas from which to collect the water. So that's the third criteria, or drainage areas. But will it work? And that's the question Supicha asked. Are these properties in Christchurch, for example, able to play that substantial role in mitigating flooding in the future under climate change? Can it be a solution? Well, she found out. She developed this amazing new methodology called the hydrology-based land capability assessment and classification method. So you can see it's very complicated. I'm not going to go through it, but Supicha is going to talk to you about it next in her presentation. And you can also read one of the two papers that we've published. So you see them here. One of them talks about the capability of this land, and the other talks about the methodology itself. We evaluated the flood mitigation capability of all industrial land within Christchurch's 6 subcatchments through time under the IPCC scenarios and a variety of storm sizes. We found that existing industrial land in 3 of these catchments could provide substantial flood mitigation capability through time to supplement that of the existing public flood infrastructure system. To give you an idea of this capability, let's look at the results for just one of these catchments called the Heathcote. This catchment was the most capable of the 3. In terms of our 3 key characteristics that this land has to have, it had relatively large areas for building GSI, reasonable depths to groundwater, but the characteristic that made this catchment outstanding was its ability to capture 30% of the catchment's water, 7% from its own land, just the water collected from its own land area, and 23% upstream if we design it that way. So this is what this catchment has to look forward to in terms of increased catchment runoff under the IPCC projections. So you can see it here that according to the different scenarios, both immediately and in the long term. So I'm going to show you how this increased runoff is reduced as the GSI, or the green infrastructure, the buckets, are implemented in this catchment. We may not be able to convince all landowners to implement the buckets, so I'm going to show you the reduced runoff and therefore flooding associated with increasing levels of implementation. If we were to collect the volume from just 5% of the catchment, so the water from a little over half of the industrial land, we can actually offset flooding impact of the major climate change scenario up to the middle of this century. Now, if we collect the runoff from 7% of the catchment area, which is collect all the water from the industrial land, we can offset flooding impact of the moderate climate change scenario, but to the end of this century. However, if we go further than this, and we collect all the collectible runoff volume in the catchment, so up to 30%, on and off the industrial land, we can then offset flooding impact just shy of the major climate change scenario up to the end of this century, so substantial capability. So what does this mean for flood mitigation planning? So what's the message to planners? What's the implication of these findings? First, planners need to design GSI as a network, which means you as designers need to think of networks, not individual facilities, but connecting them together. And this is because not all industrial properties have equal capability. Some of them might have a great big bucket available to capture water, but they don't have the water to go in the bucket. Others have the water to go in the bucket, but they don't have the bucket. But if you can connect them together in networks, you can capture all their capability and really solve the problem. So think in terms of networks is the first implication. The second one is we need collaboration. This is new type of planning that's required at this level. So you need collaboration between municipalities, communities, and private landowners so that they work together and can implement it and manage these networks. And lastly, you need to celebrate the co-benefits of green stormwater infrastructure. They don't just contain water, these facilities. They have all sorts of other benefits that we can capitalize on and convince private landowners to implement GSI on their land. Now you might say, gee, this is kind of a radical idea. Now we're used to developing radical ideas as landscape architects, but this one actually has some historical precedence about it. But these types of industrial networks and co-governance structures are not new. They're called eco-industrial complexes or parks, these networks. They were first developed 50 years ago in Kalundborg, Denmark in about 1972. They're originally set up to trade waste materials and energy between different properties. So one company might have excess heat and another company may need that heat. So they started to trade these different resources and had great benefits for mitigating environmental impacts, but also provided money for these companies. They sold their excess waste and energy to other folks, and it was an increased way for them to make profit. So what we think is that maybe we can design them to hold and trade our excess surface water. And look at all the benefits that we'll enjoy if we do this. We can enhance our park system, improve surface water quality, enhance biodiversity in the city. For communities, we can increase our recreation system, support environmental education, improve our community aesthetics. And for our business owners, we can help them achieve their water quality regulations, improve industrial aesthetics, attract and retain employees, and enhance branding and certification, help them to sell their products in a differentiated way. So to wrap up, we have two choices. We can put our money into building taller and more expensive infrastructures like walls and dykes, and lose our beautiful view of the river. Or we can strategically identify high capability properties for GSI implementation, or buckets, to hold our surplus water and implement them as needed, especially buckets that are wide and deep with large drainage areas and are connected. The choice is ours. The flood is coming, and I think we better bucket up. Thank you.